There are moments in history when technology moves faster than the world is ready to understand. Wars accelerate invention, fear drives experimentation, and secrecy hides achievements that may not be fully revealed until decades later.
Perfect. Now for the gear.
During the 20th century, few periods demonstrated this more dramatically than the years surrounding the Second World War. Germany invested immense resources into research and development, creating weapons and experimental technologies designed to shift the balance of conflict. Some became well known, others remained hidden, buried in archives, sealed facilities, or forgotten testing grounds. And in rare cases, discoveries made long after the war remind the world just how advanced and how desperate wartime innovation had become. In the closing stages of the conflict, the German military faced overwhelming pressure. Allied forces advanced from multiple directions, supply chains collapsed, and industrial infrastructure was heavily damaged. Yet research programs continued. Scientists and engineers pursued radical ideas, from propulsion experiments to guidance systems and unconventional aircraft structures. Many of these projects were rushed, incomplete, or never deployed operationally. Documentation was scattered, prototypes were destroyed, facilities were abandoned. When the war ended, intelligence teams from multiple countries moved quickly to recover technology and personnel. Much was collected, studied, and integrated into post-war scientific programs. But not everything surfaced. Some projects disappeared into obscurity, either overlooked, misidentified, or deliberately hidden during chaotic retreat. Decades later, historians and researchers began re-examining archival archives. Declassified documents, recovered engineering sketches, and archaeological site investigations slowly reconstructed fragments of lost programs. One particular case captured attention. Evidence pointed to a weapons system that had undergone development but had never been fully disclosed in public historical discussion, not because it was supernatural or mythological, but because records were incomplete and its relevance uncertain. Initial clues emerged through archived correspondence referencing experimental testing in remote facilities. Technical language described guidance calibration, stability challenges, and power limitations. These were not fantasy concepts. They reflected real engineering effort. Investigators eventually connected these references with physical remnants discovered in a neglected storage site. Corroded mechanical components, structural fragments, and instrumentation housing suggested a prototype device designed for precision targeting. Analysis indicated that the system attempted to improve accuracy compared with earlier technologies. Engineers were exploring methods of directional control that could maintain trajectory beyond traditional manual adjustment. Such experimentation was part of broader wartime innovation trends. Nations on all sides sought ways to reduce human input once a weapon was launched, increasing efficiency and reliability. The discovery illustrated how rapidly this field had progressed. Understanding the context is essential. Wartime research often prioritized results over refinement. Projects overlapped. Teams worked under intense pressure. Failures were common and frequently undocumented. The recovered material did not represent a finished operational weapon. Instead, it offered insight into developmental thinking, the transitional stage between concept and deployment. And that stage is historically valuable because it shows process. It reveals the experimentation that shaped later technologies across multiple industries, including aerospace and navigation. Public reaction to such findings is often dramatic. Headlines speak of secret superweapons or hidden power. Historians tend to take a calmer view. Most rediscovered technologies represent incremental advancement rather than revolutionary transformation. They demonstrate ingenuity, but also limitation. Materials degrade, design constraints appear, manufacturing capacity restricts implementation. Still, their rediscovery deepens understanding of technological evolution. Another dimension of this story lies in secrecy itself. Military projects were compartmentalized, workers knew only fragments, documentation was coded or restricted. When collapse came, coordination vanished. Some facilities destroyed records intentionally, others abandoned them unintentionally. Time completed the erasure. Thus, rediscovery decades later is not unusual. It is a natural outcome of fragmented history being reassembled. Modern examination of the recovered components involved multidisciplinary collaboration. Engineers assessed structural properties, historians evaluated context, archivists cross-referenced documentation. Gradually, a clearer picture emerged. The secret weapon was less a singular object and more a snapshot of experimental progress, a piece of the broader technological race unfolding during the war. It represented ambition, pressure, urgency, and the willingness to explore uncertain pathways. Its concealment for 70 years was not due to extraordinary power or hidden danger. Rather, it reflected how easily unfinished projects slip between historical categories. Not deployed, not famous, not prioritized for early study, simply overlooked until curiosity returned. In the second half of this documentary, we will explore how researchers reconstructed the full narrative surrounding this discovery. We will examine how archival breakthroughs filled missing gaps, how modern technology allowed deeper analysis, and what this rediscovered system ultimately reveals about innovation under extreme conditions. Because sometimes the greatest historical insights come not from legends, but from rediscovered fragments. When researchers began assembling the scattered evidence surrounding the rediscovered wartime technology, their goal was not sensational revelation, it was understanding. Fragments of machinery, partial documentation, and contextual records were carefully analyzed. Each piece contributed to reconstructing the environment in which the system had been conceived. The picture that emerged reflected urgency more than dominance. Innovation under pressure rarely produces polished perfection. Instead, it reveals adaptation, improvisation, and risk. Engineers worked with limited materials, shifting priorities, and uncertain futures. Their work was driven by necessity, not clarity. One of the most important breakthroughs came when archived technical drawings were compared with the recovered components. Alignment between measurements and structural elements confirmed that the prototype belonged to a guided weapons research effort. Such programs were experimental attempts to improve targeting precision. Manual control methods were being supplemented by mechanical stabilization and directional calibration systems. These approaches would later influence broader technological development worldwide, but in their wartime form, they were incomplete, sensitive, unpredictable, difficult to manufacture consistently. The rediscovered material showed evidence of these challenges, reinforcing that progress often involves trial and limitation. Modern analytical tools allowed investigators to examine the construction in ways impossible decades earlier. Microscopic material inspection revealed stress patterns. Digital modeling recreated potential operational behavior. Simulation suggested that the system might have demonstrated partial functionality, though reliability would likely have been inconsistent. That conclusion fits the historical moment. Late war conditions rarely allowed extended refinement or deployment. Many promising concepts remained experimental due to logistical collapse or shifting strategic priorities. Discovery such of a prototype, therefore, tells a story not of hidden dominance, but of interrupted development.
Ethical reflection also plays a role in interpreting technological rediscoveries tied to conflict. Scholars today approach these subjects with awareness of human cost. Innovation during wartime cannot be separated from suffering surrounding it. Technical achievement does not justify destruction. Understanding history requires acknowledging both. This balanced perspective guides responsible documentation and presentation. The objective is knowledge, not glorification. Another fascinating outcome of the investigation was how international archival collaboration contributed to understanding. Documents preserved in different countries filled gaps left elsewhere. Historical reconstruction became a global effort. This cooperation reflects a powerful contrast to the competitive environment that originally produced the technology. Where rivalry once drove secrecy, shared scholarship now promotes transparency. History evolves through dialogue. Public fascination with hidden weapons often stems from imagination shaped by popular culture. Stories of unstoppable machines or world-altering inventions attract attention. Reality tends to be more grounded. The rediscovered system demonstrated engineering creativity and determination, but also constraint. Materials, production limits, and testing challenges shaped its outcome. It was not a mythic object. It was human work, complex, imperfect, and contextual. Preservation of recovered artifacts ensures that they remain educational resources. Museums, research institutions, and archives present such items to illustrate technological progression rather than sensational mystery. Visitors encounter not just objects, but narratives explaining their creation and implications. Through this process, the past becomes accessible, understandable, and instructive. The broader lesson revealed by rediscoveries like this lies in perspective. History is not composed solely of major turning points. It also includes unfinished experiments, abandoned prototypes, and overlooked ideas. These fragments show pathways considered but not completed, possibilities explored but not realized. They expand our understanding of innovation's landscape. 70 years of obscurity did not diminish the value of the rediscovered system. Instead, the passage of time provided context. Distance allowed objective analysis. Declassification enabled openness. Technological progress permitted deeper study. Sometimes knowledge requires waiting. Ultimately, the phrase secret weapon captures imagination, but the deeper story is about curiosity. Researchers asking questions, investigators following clues, scholars assembling narratives from fragments. It is a reminder that history is never entirely settled. New discoveries reshape familiar understanding, and the pursuit of insight continues. When we examine remnants of past innovation today, we do more than study technology. We observe determination, fear, creativity, urgency. We see individuals confronting uncertainty, attempting to build solutions within the limits of their time. That human dimension endures beyond conflict itself. The rediscovery of Germany's hidden wartime project does not redefine global history. It does not introduce mythical capabilities or rewrite established timelines. What it does provide is perspective, a glimpse into experimentation under extreme pressure, an example of knowledge nearly lost, a testament to ongoing exploration of the past. And perhaps most importantly, it demonstrates that even decades later, history still has stories left to tell.